poor and thin, cried for Mother Nature to come back for them.
Try to lock it in.
I got guns in my head and they won't go. Spirits in my head and they won't go. I got guns in my head and they won't go. Spirits in my head and they won't go. But the gun still rattles, the gun still rattles. Oh.
Hello and welcome to a very special Math Monday live here at the Calgary Folk Music Festival on Princess Island Park. I'm having a great time. As you can hear, there's a lot of sound around me. There's a lot of ambient stuff going on. So I thought it'd be great to just keep talking about sound and how it works. So today's gonna be a little bit more physics than math, but I still think it'll be fun. Do you guys know that how sound actually works is it's just moving the air particles? That's all. It's just the vibrations of air particles, and that's what creates sound for us, which I think is pretty fantastic. So what you get is air particles bunching up together in one place and then spreading out in another place. So that's actually called a sound wave. That's called a longitudinal wave, meaning it's moving back and forth, not up and down like this. However, when drawing sound waves, we often draw transverse waves because they're easier to draw and it's easier to see the different properties of waves on a transverse wave. So those peaks of the transverse wave, those highest points, correspond to where the air particles are closest together, and then the troughs, or the lowest points, correspond to where the air particles are farthest apart. From the distance from the top of the wave to the bottom divided by 2, that is your amplitude of the wave. That's really, really important. We have the wavelength. That's the different distance between the lowest points or the highest points. Basically how long the wave takes to start repeating itself. That's the wavelength, which is also very important. And wavelength has to do with frequency. Frequency is really important. It's how many times a wave passes through a point in 1 second. Okay, so we can actually determine the velocity of waves using frequency and wavelength. It's actually wavelength times the frequency. So we can figure out the speed of sound using that. We can figure out the speed of light using that. That's a pretty important equation. It's even called the wave equation. So that transverse wave right there, that's actually the graph of sine x. It's a pretty important graph. In physics, we use it all the time. So there are a few different things that are affected by these different properties of a wave. First off is pitch. Pitch, that's how high or low a sound is. So if I talk really, really high or really, really low, that's its pitch. That's affected by frequency and wavelength, since those two are related to each other. So if I have a really high sound, that means that you have a higher frequency, which actually is corresponding to a shorter wavelength. So that means the peaks are closer together and the troughs are closer together. Or the bits of air where the air molecules are really scrunched together are closer together, and the bits of air where the air molecules are spread apart, those are closer together as well. So you just take that whole wave and bunch it together, and that'll correspond to a higher pitch sound. A lower pitch sound, that means that you actually have a lower frequency, which means you have a bigger wavelength. So the waves are really, really spread apart. The peaks are spread apart, the troughs are spread apart. So in that case, we're not changing the amount of air molecules in the air, we're just spreading them out or bunching them together. Loudness, so how loud something is, the volume of something, that's actually affected by the amplitude. Amplitude is really, really important. So that's how high and low the wave goes. That doesn't necessarily mean that we're changing the wavelength. You can still have a wave that has a really high peaks and really low troughs, but with the same wavelength. So I know that amplitude affects loudness because last week we went over that formula that sound intensity is equal to power divided by the area that it's spread over. But power is actually equal to energy over time, and energy of a wave is 1/2 K, that's just the wave constant, it's different for every kind of wave, times the amplitude squared. So therefore, amplitude is actually related to the sound intensity. If you want to put all that together, and if you don't like putting formulas together and all that stuff, just trust me, I promise it's right. The sound intensity is equal to 1/2 K times the amplitude squared divided by the time times the area that it's spread over. Basically what that means, if you double the amplitude, sound intensity is going to go up 4 times. If I triple the amplitude, the sound intensity is going to go up 9 times because we're squaring the amplitude. So it's actually called a square proportion. So affecting the amplitude a little bit really affects the sound intensity. So what does it mean to affect the amplitude of a sound wave? It just means that you're fitting more air particles into those places where we have them all bunched together. They're really tight in there. Again, we still keep the wavelength the same, so they're spread out at the same rate, but we're just fitting more in there. And that's how we affect the loudness. We just make the vibration of the air particles a lot faster, and that's how we affect how loud something is. And that's why when you're standing right by a speaker, what a speaker does is actually has a cone that it moves the air back and forth. So if you're right by there, you're right by where it's moving all the air, so it's louder there. And if you go farther away, it's not as loud because the air isn't moving quite as violently around you. So that's why you shouldn't stand next to a speaker. Anyways, that's all I have to tell you about sound today. Obviously, I could go into way more. Why is sound different? Why does the pitch change when you move? That's all about the Doppler effect, and we can go over that another time. But for now, I'm gonna go enjoy the Folk Fest, stop talking to a camera. I hope you guys had a great weekend. Happy Math Monday. I'll talk to you later.
Oh, I'm just waiting on